It was such a bleak picture. Communities were devastated by the HIV/AIDS epidemic. This was a death sentence. We all would see patients, who were going to be dead in a matter of weeks to months. So there was a tremendous sense of urgency. We worked all the time, every night, on the weekends. The whole team felt it was essential to have a really terrific clone, a molecular clone of HIV, so that the drug developers could do their thing. The clone was developed in 1985, and there were 11 inventors on the patent. You now had a toolbox to really attack the pathogen. One of the major developments in HIV therapy was an inhibitor of an enzyme called the protease. And one of the companies that really came out with the first protease inhibitors used pieces of that clone that our team really developed. It's rather gratifying. It's the most heavily used clone and has been for decades now. I had incredible parents who were both scientists at the National Institutes of Health. I would go into the labs with my father and he'd walk through and look at what was going on under the microscope with his experiments. I would play around with tissue culture, with growing cells. I was at Sidwell during this amazing period of transition. This was the Vietnam War era. And I was a co-chair of the Student Mobilizing Committee to End the War in Vietnam. And we marshaled at the big marches in '69 and 1970. And the incredible thing was that my teachers were there too. So we were all in this together. The Quaker values of nonviolence, speaking truth to power, were really in abundance and really had a long-lasting impact. I remember days when I would run into the lab from the parking lot at NIH, which was usually half a mile to a mile away, because I couldn't wait to see the results of the experiment that I did yesterday. Our lab was very involved in understanding the process of latency control. And that is a central theme of efforts to cure HIV infection, is how to block or get rid of the cells that are latently infected. That's an area that I think we had particular sort of impact in. I met my wife, Barbara, who is the love of my life, in 1988. My career was on the rapid ascent, so there were numerous possibilities for me in the New York area. The Center for Advanced Biotechnology and Medicine, the CABM, was a new institute, part of Rutgers. I came up to visit, and it was like, these are my people. They were all pure scientists, which means someone who does science for the love of it. Our work at CABM really still was continuing with HIV and what regulated latency, and that's when we discovered these alterations of this NF-kappa B protein in T-cell lymphomas. So that then shifted the work very much into cancer focus, and the move into cancer coincided with the development of a cancer institute here at Rutgers. The administrative piece is very fulfilling, but very different. I'm involved in recruitment of young scientists, and I view my major effort as helping them succeed. So I come into work every day with the goal being, who's doing what and what can I do to help them. The most rewarding aspect of my job now is watching young people that I've hired, that I've helped mentor and support, become leaders in breast cancer research, young neuroscientists who have emerged to be spectacular leaders in their field. We did some fun things in the 80s and the 90s on HIV and cancer, so I'm happy and proud that some of the science has been helpful. On the other hand, to watch a young scientist contribute cutting-edge science that moves a field along, that is the most satisfying and most rewarding aspect of what I've done.